So in the previous lesson, I discussed linear functions. So here in this lesson, we have quadratic functions. And really what quadratic functions means is that there's a degree of 2. So as there was a degree of 1 in linear functions, there's a degree of 2 in quadratic functions. So just to give a brief overview, the form that you will usually see is y is equal to ax squared plus bx plus c. And that's usually the form of quadratic functions. And so if we just take the basic function, or also known as the parent function, f of x is equal to x squared, when you graph this, you will see a parabola, something like this. And so the point will be on the origin 0, 0. And so you usually see that with quadratic functions, there's a curve. With linear functions, there was a line that was being graphed with a constant rate of change. With the quadratic functions, you have a parabola that's being graphed. And so this is one standard form that you can use, ax squared plus bx plus c. And the other form that you can use is the vertex form, which is also crucial. So that is y is equal to a times x minus h squared plus k, where h comma k is the point of the vertex. And so really, when you're determining the vertex, it's important that you find the x coordinate, which can be determined by this formula, negative b over 2a, from the standard form. So if you have anything here in the standard form, you basically do negative b over 2a, and then you get the x coordinate of the vertex. And so once you get the x coordinate, you can obviously substitute that back in the equation to determine the y value for the vertex. And so here I have a easy example listed here. So for instance, if you have something like f of x is equal to x squared minus 7x plus 12, clearly you can factor this. Usually what I do, and many others, is that just find two numbers whose product is 12 and whose sum is negative 7. For instance, in my mind, I know that negative 4 and negative 3 have a product of 12 and a sum of negative 7. And so really, I know negative 4 and negative 3, so I substitute those values in, and I'd say x minus 4 times x minus 3 is equal to 0. And really, when I'm determining the solutions, I'm setting the quadratic equation to 0. And so what this essentially means is that each factor could be 0. If this factor is 0, then the entire evaluation would end up being 0. If this factor becomes 0, then again the entire evaluation would be 0, which means that you would set x minus 4 to 0, getting x is equal to 4 as one solution, and you would set x minus 3 to 0, and you would get 3 as the other solution. And really, these are the x-intercepts, also known as the zeros or the solutions. But it's important to understand that with quadratic functions, the number of zeros, or the number of x-intercepts that you will see, is 2. And so, again, using factoring, you see that there are two distinct solutions here. However, in some cases, you may only end up deriving one, 0. But then you have to understand that that 0, that solution, may be repeated twice. For instance, before I even go into that, I want to discuss another problem where the a value can be greater than 1. So here, for instance, if you have something like a being greater than 1, like 3x squared minus 13x plus 12, you have to again look at product of two numbers which is 36 and the sum which is negative 13. And really, as in this one, I had just said the product is 12, which was c. Really what I did was I did 12 times a. That gave me 12. Similarly here, to find which two numbers have a product of 36, I'm really multiplying 12 and 3 to state that the product of the two numbers must be 36. So essentially you're multiplying c by a to determine the product. So in this case, we know that the product must be 36, and the b value gives the sum, which in this case is negative 13. And so using the same idea, in this one, you have to show more steps. So you have to think of those two numbers, which in this case are -9 and -4. So you splitting -13x into -9x minus 4x. You know that 9 and 4 have a product of 36 and a sum of -13. You can further factor this out. Getting 3x on the side, you have 3x times x minus 3 minus 4 times x minus 3 is equal to 0. And of course, you can then bring 3x minus 4 as one factor times by x minus 3, giving 0. And as I previously stated, that each factor must be 0. That's where you're getting this as 0. And so you get 4/3 and 3 as your solutions. And so as I was talking about a case where you may get repeated solutions, this is a great example. For instance, f of x is equal to x squared minus 4x plus 4. You want to set this to 0, and factoring this out, you get x minus 2 squared. And so really what you see is that 2, 0 is the 0, and that's the only solution you really have based on your factored out number values. So you have to state that 2, 0 is a solution that is repeated twice, because as it's a quadratic function, if you're only getting one function, that function in fact has been repeated twice. So that's the idea. And then at the same time, as we discussed earlier with linear functions, x-intercepts, y-intercepts, you can do the same idea, but if you think about it, the x-intercept in this case is really the solution. It's the value of x when y is set to 0, which in essence is your solution. So the x-intercept here would be 2, 0. The y-intercept, it's the value of y when x is set to 0. You could plug in 0 in for x, but really the easy way is that c is usually going to be your y-intercept. So you know that off top of your head. So you have x squared minus 4x plus 4. That means that 0, 4 is your y-intercept because c is 4. And there are two other formulas that are usually tested on the SAT as well. And they're good formulas to know for quadratic functions. One of them is the product of solutions is equal to c over a. And the sum of solutions is equal to negative b over a. So those are the two ones you definitely want to know. And just checking your work, you know that here the two solutions are 2 and 2. Their sum is 4, and their product is also 4. And if you do c over a, 4 over 1, that's 4. And if you do negative b over a, negative times negative 4 is 4, over 1 is also 4. So obviously 2 and 2 have a product of 4 and a sum of 4. And so really, this is the basics of quadratic functions, but usually what happens is at times, things aren't easy. You can't factor out what you're given. So in that case, you have to use either the quadratic formula or you have to do the completing the square, in which you cannot factor out the factors or whatever you're given with. So here's an example. For instance, if you have something like y is equal to x squared minus 7x plus 11, you can either do completing the square. I prefer this method over the quadratic formula because all you're really doing is you're moving the constant over and you're ensuring that a is equal to 1. It's highly important that you make sure that a is set to 1, whether that means you have to factor the other constant out. But in this case, you already know that a is 1, so we don't have to alter anything. But of course, we have to move the constant to the other side, which makes this negative 11. So negative 11 is equal to x squared minus 7x plus something. And usually, when you want to find this something value, you have the b value. You want to divide the b value by 2 and then square the entire thing. So negative 7 divided by 2, and its square gives you 49 over 4. And so really that's the idea. You have b, divide that by 2, and then square the result. And so you get 49 over 4. And so really you're adding 49 over 4. But if you do that to one side, you have to do that to the other side. And so when you have x squared minus 7x plus 49 over 4, you see that this actually becomes, it can be factored out into x minus 7 over 2's square, right? And you add this here and you get 1.25. Now you can easily solve this because you have a square here. So if you take the square root of this, you want to make sure that you have plus or minus of the square root of 1.25 is equal to x minus 7 over 2. And then moving 7 over 2 on the other side, you get this plus 7 over 2 is equal to x. So this is the answer. However, if you don't prefer this method, you can also use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And really, a, b, c are just values taken in from the standard form. And so, plugging in those values again from here, you get the overall value being 7 over 2 plus or minus the square root of 5 over 2. And really, the square root of 1.25 and the square root of 5 divided by 2 are really the same thing. So you can basically solve it either by completing the square or by using the quadratic formula. Thank you.